This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there, welcome to a new episode of the Industrial AI podcast. My name is Peter Seeberg and I'm your host. Today I'm going to be talking to Srinivas Kuppa. He's the Chief Strategy and Product Officer Industrial at Symphony AI. Srinivas and I will talk about and around the world's first industrial AI model. Hello, Srinivas.
Hi, Peter. How are you?
I'm fine, thank you. As I just already suggested, we have the first snow here in the Munich area, so it's getting really cold.
Yeah, here in Michigan, where I live, it's getting cold as well. We had the first snow yesterday. It melted, of course, but the next several days are going to be really cold as well.
Interesting. I'm not sure how far we're apart, but a couple of thousand miles, I guess, and the weather seems to be reacting in a very similar way. So, Srinivas, please introduce yourself to our listeners.
Oh, yeah, absolutely. Peter, first of all, thanks to you for the opportunity. I am the Chief Strategy and Product Officer for Symphony AI's industrial business. Before joining Symphony AI roughly 3 years ago, I've been in the manufacturing space for roughly 20 years, working half of the time with Siemens in various different roles. Most recently, I was the Chief Digital Officer for the Carrier's global security business. And before that, I worked in the management consulting at Accenture. I worked with Dassault Systems, which is focused on manufacturing software as well. And along the way, I've also worked on my own startup. So quite a bit of it is around technology, AI, data, and really applying that into various industry scale challenges. So that's me.
That's exactly why we have you here at our Industrial AI podcast, Srinivas. So tell us a little bit more. Give us an overview of what Symphony AI does.
Yeah, absolutely. Symphony AI is probably one of the world's largest AI SaaS company. In other words, our software offering is predominantly SaaS and predominantly wrapped around with AI capabilities. We are a pretty large company with key focus on getting into IPO sooner than later. Symphony AI is made up of 4 major business areas. One is industrial. The other one is fin services. Then we have retail and CPG and enterprise IT. We focus on other businesses like media and trading platform as well. But together, Symphony AI is really built in to take AI platform, which is, think of that as a horizontal, and then applying that to the business problems and offering those solutions to the customers that can solve the problem at scale. So that's our goal. We have started in the year of 2019, roughly around that time, but we have grown through acquisitions and organically as well. So there's a lot of history around the technologies we offer, the customer base we have, and the success we're seeing in the market.
What a wonderfully, compressed way of representing your company, AI SaaS, artificial intelligence software as a service. I guess what is the typical question, explain your manager, your CEO. I recall from my Intel time when you have, like 10 seconds when you get into the elevator, you would only need almost 1 second to explain it right. AISAS. Thank you for that. You call yourself a generative and predictive AI leader. Please tell us more about that.
Yeah, absolutely. So as we all know, the generative AI part of it took off in the market adoption, market validation, and everything around it since ChatGPT came out with its first version roughly a year and a half ago. But before that, AI existed, and let's call those models all put together as predictive AI. There are 2 buckets of it. One is all around predictive AI, applying neural networks or regression models or anything that we wrap around big data with statistical models and really apply self-learning capabilities around it for classification and purposes. Let's call them all predictive AI. And then once you get into the natural language processing, natural language generation, and really taking that to the next level of large language models, which can communicate through in a conversational model and have large amount of knowledge being built into it. That's called the generative AI. So what we have done at Symphony AI is we have always been able to successfully bring in these AI algorithms that are being wrapped in, trained with the data, and deployed for the customer's use cases to generate value out of it. So we built in the whole layer of what we call as the AI workflow. In other words, from really writing a piece of Python code to providing the data to that Python code, converting that into an actionable model, deploying that model, and then training it end to end. That's one part of it. It's just covered in the AI model. The second part of it is really how can these models be most effective? How can these programs be written in such a way that they are more context driven, that can solve very specific industry use cases, but do so at scale? Are we really bringing the models from somewhere else and then trying to train them? Or are we really building them with all the domain knowledge that we have built in over time? There again, we have built in all this domain driven knowledge, pieces of code that we then again train on customers' data. So we have built in this whole layer of AI workflow and then these optimized algorithms that can be applied to very specific use cases at scale. That's one. Since the large language model, initiative came in, we went in thanks to a lot of data that we have been sitting on top of because of various activities we have done in the last 50 plus years. We anonymized all the data and then trained and created our own large language model. So in other words, we took a foundational model, trained with extensive amount of data, and built a highly focused, grounded model that is focused on reliability and maintenance side of the whole manufacturing space. And so together with what I said on the predictive side, the AI workflow, as well as the new introduction of the large language model, we are really solving the customer's end user problems on the manufacturing side, reliability and maintenance, logistics, and supply chain areas. So that makes us really a leader in this space because looking at our competition, people are doing pieces of it, but really bringing that whole extensive layer into a platform with ready-to-use solutions. And that's where we differentiate ourselves.
Very good. We're going to be concentrating on the Gen AI, on the large language model in a couple of minutes. Now, I assume, and maybe you can share with us that you did not, I'm not sure, you start your company with it. There is like another range of products I saw. Maybe you want to share with our listeners what let's say, the environment of your offering as being grouped by specific names, I guess. So maybe you want to share with us what it is that they do specifically.
Yeah, absolutely. So the strategy we have is quite simple, right? If you look at the manufacturing space as a whole, there are three elements that really play in. One is the people side, the maintenance technician, the production manager, and all these people who need to be really augmented with content and help them make some key decisions. Then there is a process side of it. A lot of manufacturing processes there. It's very complex. A lot of events happen on the shop floor that you need to be responsive to. In some cases, you need to predict the process impact and take alternative decisions. And then there's a third element that is equipment itself. The equipment's failure, its health, its capital cost. How do we really have a replacement equipment? How can we manage the impact? Now the sustainability side is kicking in as well. But nonetheless, people, process, and equipment are the key focus in the manufacturing space and manufacturing connected supply chain. Now, our application ecosystem includes solutions that cover all three sides of it. On the people side of it, we have what we call as augmented connected worker solution. That's all about mobile device and multi-device enabled, right down to the wearables, where end users can perform activities like instructions, inspections, work order execution on the shop floor or out there on the field. Now, this is enabled with state-of-the-art technology where the end users can see the data coming in from other sources in what we call as the packageable byte content, what we call as a cognitive payload. And this information enables end users to perform the best job possible. Now, we enable that with the Copilot capabilities as well, but we'll get to that in a minute. Now, on the Copilot side, on the connected worker side, it's incredible because just recently Frost & Sullivan rated us as number one in the market for this particular product. Moving on the process side, we have what we call as Manufacturing Operations Management 360, which we also call as Manufacturing Workflow Intelligence. This is all about improving the material tracking, improving the process side of it, as well as the quality side of it. So we have three major models that come in: material flow, process flow, and the quality flow, which make up the whole manufacturing operations management solution. Here again, we have customers. Some of them are actually using it across 400 plus plants, running their food operations. Some customers are using it running 55,000 workflows in a given month, carrying major data sources and configurations through integrations using this technology. Then the third one is the equipment itself. From predictive maintenance to asset performance management, asset health, the whole cycle of it, we are tracking it using our asset performance management solution. So these are the three capabilities, but they all sit on top of a layer of the platform, which we call as the Iris Foundry, which contains three layers. One is the connectivity to the data sources. Then what we call as a unified data model, which is all about contextualization of the data. And then we call as the knowledge layer, where we create the whole knowledge graph of the data and then feed it to the end user applications through AI.
Okay, knowledge graph we're going to come to in a minute as well. I want to know what their role is in your total offering. You're very good at painting a picture in my, and I assume in our listeners' brain, who are typically listening. Maybe they're driving to work or whatever. So breaking it down, splitting it by people, process, and equipment. Very nicely done. Thank you. So let's zoom into the industrial LLM, which I was kind of surprised to see your announcement a year ago. Still, I was very happy to stick to what at that time you called it the world's first industrial LLM. My business partner, Robert, and I have discussed the need for industrial language models, for foundation models. You already talked about that quickly for a couple of years, actually, in our industrial AI podcast conferences. Now, in the meantime, I guess we've seen them from here and there. You claim that you were the first. As I said, it was announced about a year ago. So let's talk. You did kind of a quick introduction. One question I had already, you suggested you took a foundation model. So you may want to start there or tell us a bit more about what it exactly does and what foundation model it was actually trained on.
Yeah, absolutely. So when we looked at, the announcement of ChatGPT, and then came a few foundational models very quickly, the challenges of those models were also very evident, right? That is, they're all trained on very generic data. They provide good responses, but they hallucinate a whole lot. Even though the things have gotten better along the way, they still hallucinate. The primary reason is because they are trained with such a broad set of data that they obviously have broad set of tokens that they can respond with, and that creates hallucination at times. What we looked at is, over time, the need for these language models would come in handy in highly expert driven scenarios or use cases. But if we solve two things: one, reduce the hallucination part of it, ground it as much as possible, and also have it trained into an expertise into one or two specific areas. In other words, actually, these two are interrelated. So we looked at ourselves and we said, we have had the experience of working with 80,000 plus different asset classes over a period of time. And we also happen to sit on a huge set of high quality anonymized data. When I say high quality anonymized data, it's not simply asset sensor data or otherwise. It's actually work order execution completion information, which was written in a very structured, very detailed, very accurate manner. So we looked at this kind of work order execution reports. We looked at, for example, oil change reports, vibration analysis reports, and such. We also looked at the 80,000 assets, which make up anywhere close to 60% of any industry's manufacturing plant. And we said, let's use this data and see if we can take a foundational model, fine-tune that model to the point where we can really make it grounded and become more of an expert in reliability and maintenance areas. And that's what we did. So we took Llama 13 billion at the time. We tried to take the lightest one possible because we did not want those additional tokens. Anything beyond 13 billion were probably training on more generic information that may not be needed for us. So we took the 13 billion at the time, we trained with quite a significant amount of the data to fine tune it, where now that model that we have trained and fine tuned is an expert in reliability and maintenance. Now, any of the activities that happen through our product, where you're a maintenance manager trying to interact about an asset's performance or degradation of its performance, or you're a technician who's actually on the shop floor repairing it, interact with the same co-pilot, asking for instructions on what to repair, or somebody else, a process analyst, is working on the same co-pilot asking about what are the bounding parameters and such. All of these people will now be interacting with co-pilot. Now, what we did real quick is we didn't stop there. We said there's one thing about rendering the data through these conversations, but now how can we really enrich the end user's experience? Because chatbots are hard to do in most of the industrial setups. So we made the whole conversation multimodal. In other words, it's not a chatbot on the side where you're simply doing a textual messaging, but this Copilot has the redirectional agent model that we built at the time. Now Agent AI has become a standard, but then it was not. What it basically does is, on one hand, it goes to the knowledge graph, the knowledge base, to go get data from the true source of information, because sometimes the data has to be real time. Then it goes to the large language model, summarizes the information. But on occasions, when you have to draw a chart or put up predictive analysis or update certain data parameters on the dashboard, it calls the APIs to do so. So it really takes a large language model, wraps it around a complete capability to make the end user's experience that much more effective. So that's the journey we went with.
Yeah, let me stop you here, because if not, the number of questions I have is going to raise beyond my capability to keep them in my limited space. So Copilot first as a general term, or the Copilot we all know from your partner, Microsoft?
Copilot is a general term. Of course, Microsoft certainly has pushed it and made it a term that is everybody embracing it around. But Copilot is a general term. The idea here is assuming that the large language model truly plays the role of a generic AI capable system, anything that sits on top of it and creates an interactive model on that large language model suffices to be called something that can support the main user. And the main user being the pilot, this will become the co-pilot.
Can you shed a little bit more light maybe on how you went about grounding your model? As we all know, so very, very important. And you already referred to is that maybe the hypothesis I have had it to do with the knowledge graphs that you use. Is that the way to make sure your the answers from your co-pilot are, correct?
Yes. So there are a couple of different ways we went about it, right? So one is, like you said, you need to sit on top of a highly cleansed, structured, single source of data. When I say single source of data, that does not mean all your terabytes of data sitting in various different systems need to be brought in and centralized. I'm not saying that. I'm focusing on the meta model that really understands the relationships between the data. The actual data itself need not be brought in together, but the relationships between the data need to be brought in together, and you need to create a dynamic layer around it. For example, if an asset has 7 different sensors covering pressure, temperature, viscosity, and others, then the asset also has gone through its own maintenance over a period of time. These two data pieces will be in 2 different systems. Don't bring the data back again and copy it over in the middle, but rather connect the maintenance information with the asset information, with the tag information. So just take the meta model layer of it and create those connecting the dots. That's for us is the knowledge graph, the core building blocks of the knowledge graph. But then that's not where it stops. Knowledge graph, by true nature of it, does not simply point it to the connections of the data, but goes beyond. There's a lot of activity that happens on the shop floor or anywhere for that point where the human intelligence plays a role. How do I make my batch optimized? How do I clean my incubator once I go through the process of manufacturing? So there's a lot of human tribal knowledge that kicks in that makes some of these works efficient. How can we take that information back in through AI and bring it into this knowledge graph? And by the way, the knowledge graph is not a static element, but that need to continuously, dynamically keep changing and start showing new set of patterns in real time. How can we make that happen? The combination of these things is the knowledge graph. Now, that is one of the building blocks that serves the large language model. So the large language model sits on top of something that's more established in from a data structure point of view. But that alone cannot support. The second thing that it need to really look for is the predictive models and other API calls that it may have to do to do some kind of a data conjunction. That's a second piece. Now we use these layers underneath to start grounding the large language model itself. Now, but then again, the large language model is a black box, right? In other words, you cannot objectively say this result, this large language model is providing it in a better way than the other. So we had to apply certain AI methodologies to it. One thing we did is we created the concept of explainable AI, or we should say we didn't create, but we use the concept of explainable AI. In other words, the model tells you how it concluded, how it summarized, how it's drawing the insights, but it actually shows the whole flow of how it was able to get to that conclusion to enable an end user, a human, to validate and say, yeah, the approach that you have taken to come to the conclusion is right. Based on this kind of a closed loop feedback over a period of time, the model is able to really respond to it and become more and more grounded over a period of time. That's the approach we took. And of course, we did some benchmarking as well, where we took a very deterministic system. We took a standard 2 or 3 different large language models. And then we took our model and we started benchmarking it across 15 different use cases, anywhere from insights to summarization to prediction to various different major factors to see the response time, the accuracy of it. And then we use the human element to validate the responses. So we use some of these metrics to really conclude that our model is much more grounded.
Okay, I like the XAI approach. We've talked about it before here in the Industry AI podcast, and probably actually for the European market, probably from next year on, for any company that wants to provide in whatever area AI-based solutions will have to break down, open up along the lines of what you said. So should you be interested, we'll talk about that in the end, or already providing your services on the European market and want to continue to do so. That's a very interesting approach. Yeah, I think in the end, before any solution from any large language model is actually presented to the user, we're going to need to, number one, or in general, let's say, as you do, follow some kind of XAI approach and check that the answer it is going to give makes sense. You talked about anonymized data. Can I assume that you have been allowed to? Is that part of the deal we talk about later, or just in a moment about the offering you have to your customer, that this data is actually customer data, and as you say, anonymized, but therefore still data from the services, the classes, the assets from your customers?
That's a great question. So let me address it this way, right? First, I want to address the customers that we have today and the customers we will potentially get in the future. Our model does not train from your data and somehow make it accessible to somebody else. That's not going to happen. And I would like to stress on that a little bit when we talk about our architecture, the data privacy, security, all the pieces we bring in. Now, having said that, we happen to have, through contributions or otherwise, a set of data from the past across multiple different assets that have performed, where we had the work order execution reports. And this is something that we had access to through agreements from our customers and partners as such. And then we completely anonymized the data. We only took the key outcomes, for example, we say, how old is the asset? What kind of a maintenance activity is done? If the oil change has been done. When the oil change was done, have you replaced the motor gearbox? Well, you have not. So 7 out of the 10 times you don't do that for a 3-year-old motor of this class. So we kind of gathered that kind of information there. For example, there's nothing about the customer. It's just about the know-how. But even that information, we have done it through the right ways, anonymized it, and used that as a learning process. Now, however, moving forward, when we offer this model to our customers, number one, this model runs within the firewalls of the customer if they choose to do so. Or it can run in their own equipment. When I say equipment, they're computer infrastructure, it can run it in there. Unlike other models such as OpenAI and others, where you are forced to create an API call, and sometimes the model is running in a separate infrastructure that you don't have access to. Here, the customers can choose to have this model deployed within their firewalls or within their private cloud setup that they have. That's number one. Number two, what we have also done is even when the model is being used by the customers in production or in their test equipments, we don't fine tune the model with any additional data that comes from the customers. There, we use a RAG approach. That is, the customer's specific data is packaged into a vector binding and then kept it separate from the model itself. So any of the prompts that come in where the vector bindings need to be used to provide the responses, it does so. Once you choke the access or remove the access to that vector bindings, that set of information and responses will not be providing any feedback based on the knowledge that's been built into these vector bindings. So that way, think of it this way, the model itself, which we bring in out of the box, is a fine-tuned model. It can be deployed wherever the customer wants. And then on top of it, as and when the customer data is interacted, it is completely separated out into a vector binding. That way, there is no real cross-pollination and no data gets into the wrong places.
Right. So if you as a customer have data, and we discussed that a couple of times in the past, as I just referred to, the big companies have loads of data. The small companies, they have the bigger interest in, receiving in some kind of, let's say, open source. But as you say, very important, I believe, number one, if it's your data, you can decide what to do with it, and it's only for you. I was going to ask you, and I feel, as long as we've been doing this for about 6 years, that you already gave a potential answer to a question: where does it run? You say it can run anywhere in the cloud, if that's, or on your private. That's another typical thing, at least in Europe, that has always been. We'll talk about in a moment in what 33 countries, not necessarily all of them, but in what regions of the world you are active. So a little bit moving forward towards the industrial LLM as what? Is it a product? I mean, do you sell it? We've had the discussion now for a couple of months. Is companies, I guess, like your own, and that's why I'm very interested, are looking towards monetizing. So, do customers pay for a specific product that you call LLM?
Yeah, so we have different ways we package our product, but just to give you the big picture, the product we sell is Iris Foundry. Iris Foundry is our complete AI data ops platform. In other words, from connecting to the data sources, creating, transforming the data, creating what we call as a unified data model, and then graduating that to a knowledge graph, and then applying the AI models, either the large language model or the predictive models, and then rendering that information into each of these applications we talked about for people, process, and equipment. That all is highly modularized, but we sell that as a platform. Now, the way I'll give you a couple of scenarios the customers would come and buy this. Some people say, I want to start with predictive maintenance. I have a fleet of 200 assets in 3 plants, and can you do predictive maintenance? Yes. They will take the Iris Foundry as the platform. We enable the predictive maintenance use case. Along with it, the customer can choose to turn on the Copilot. When they turn on the Copilot, obviously, it comes with the large language model. And the whole application suite comes in, where all they have to do is connect to the data sources. We contextualize it. We apply the AI models. We determine the anomalies. We help the end users communicate through the Copilot or through the dashboards, and then perform the predictive maintenance tasks. So, and then the customer then might say, okay, no, I want to go start creating a digital twin and doing process optimization on my highly critical assets. Then it's another use case that sits on top and pretty much goes through the same approach. On the large language model itself, we don't separately sell that as a pricing, but it is packaged within the platform.
Okay, yeah, I guess I understand that. So if they tick Copilot, then that means that there is a dollar amount related to that, but you don't offer AI as such. You don't offer LLM. It's because you integrate it into your service offerings, and that is what people can choose and then pay for.
That's right. I think talking to a lot of customers, we do this on a regular basis. We interview a lot of customers and potential customers, look at how we position our product into the market. I think you can obviously take our large language model and the layer of Copilot and then say, how can I start using that as a standalone in a customer's environment? Yeah, I mean, that is surely possible. But typically, what happens is now you need to connect to the data sources. You need to pull the data from various different sources. You still have to create the vector embeddings. You have to then create the knowledge graph. And then that's when the Copilot is embedded with these capabilities underneath, can perform with the best of its abilities. And that's what we are seeing 9 out of 10 times when we talk to the customers. So these underlying components become highly valuable. Now, I want to be very clear, these components are not heavyweight components. The way we have built it is it's lightweight, containerized, and they're not really impacting an existing ecosystem of infrastructure that they already have. It just sits nicely in between, connects with the data sources, and does what it needs to do for really solving the operational use case problem. For example, we connect with Microsoft's Fabric as a data lake. We connect with Snowflake, Databricks. We interact with Microsoft's Copilots. So it's not like this technology is meant to replace anything, but really work in conjunction with them and give that optimized value in the operational space.
Thank you very much, Srinivas. Tell us a little bit more about your team. We just said at the beginning, you're based in Michigan, I understand, which are not the 33 countries I read about, but what are the main areas in the world, maybe, right?
Yeah, as Symphony AI is a global company, we are situated in quite a few continents and quite a few countries. Our head office is in Palo Alto, California. We have a large development center in Minneapolis. I live in Michigan. We have a presence in Bangalore. We have a large development center there. We have presence in UK, Belgium. Maybe I'm forgetting a few places, but we are situated in quite a few places. As far as my team goes, I cover several different functions for industrial, product management, pre-sales, global industrial solutions group, partnerships, marketing are the areas that are covered in my group. I got leaders for each of these areas, and they do a tremendous job of really taking the whole exercise end to end, really looking at what can solve customers' problems, how do we interact with the customer, build a product that fits into the market, validate it on a regular basis, market it. And when the customer is there, we present it to them using pre-sales approach, but then really drive the whole customer adoption cycle of it. So the team is really busy doing quite a bit of those activities.
So getting to a close, I have kind of two kind of looking forward into the future type of questions. Thank you very much for this great overview on what started as the first industrial large language model about a year ago. What is your global perspective? You just mentioned, you have development Bangalore, India, UK, Europe, United States. We didn't discuss China, I'm not sure, but what is your view as far as is concerned the use of large language models, specifically in an industrial environment, as we discussed for the last half hour? Where are the different markets? Where's the United States? Where's Europe? Where's the UK? Where's Asia? Do you have a perspective on that?
Yeah, I mean, we do. Incidentally, we did a roadshow in Houston 2 weeks ago. We concluded a roadshow in Dubai this week. We are going to have 2 additional roadshows, one in Europe, another one in US, and we may do one in Far East as well in the next several months. We'll be at Hanover Messe with our partners, Microsoft, Dell, and others. So it's exciting for us. To answer your question, I'll answer it focused on LLM, and then I'll step back, talk about data operations platform itself. On the large language model side, there is an absolute focus wanting to adopt and draw value out of what these tools can offer. Now, there is an element of fatigue in the market, trying to wonder, how can I solve a high value, very specific, complex use case with something more generic that is large language model. Yeah, it can answer some questions for me. It can give it some kind of feedback. Great. It can summarize a huge document for me. But I'm in manufacturing. I'm doing engineering. I have to have very specific responses and accurate ones. How can I get it? I think that's where a lot of activity is happening. Recently, the whole concept of small language models came in to address those things, to make it even more grounded. The second thing the customers are concerned about is what is the cost impact? They all run on GPUs. The insight engines, the inference engines run on GPUs. Is that going to cost me more than the value they bring? Now, with small language models, you can really run enterprise scale on CPUs. So the cost element falls down, and also the grounded element of it with less hallucination improves as well. So that's where the market is going. On the global side, US, the North America and Europe are really adopting it. I'm really surprised in a good way that the Middle East side of it is absolutely embracing the AI capabilities. And we are seeing some movement in the Far East as well. So that's how we are seeing it. For us, we see an opportunity all across the globe. And on the operations platform, I think everyone has a challenge. For me, large language model is great, AI is great, but I have data in the silos. The data is not contextualized. I don't have similar nomenclature. My ontology is not defined. Everything is a challenge. So how can you solve my problem when my data is all over the place? So the next 2 to 3 years journey will be on the data operations, creating the layer of data contextualization, creating that unified data model, creating that knowledge graph, which will then support all kinds of AI to draw the best outcome. So even though AI on the periphery is looking as a growth curve, the underlying curve of data operations is really the one that's going to draw success.
Which is then going to bring me to the final question. I just read an article you wrote, I guess about a week ago on LinkedIn. That's one place at least where you shared it. You wrote about AI growth and adoption. You talked about critical limiting factors. Actually, you have 4 major factors that may impede AI growth. Can you share those with us as a close-off of our podcast?
Yeah, absolutely. So I was looking at it from almost like an antithesis way, right? Everybody's on this AI bandwagon. It's great. It's really transformational. It's improving the productivity. It's capturing the knowledge. It's really adding the value element. But there are absolute limitations on AI. And for me, the four limitations that were pretty visible are the energy consumption. AI models are huge. And like I gave some references on what kind of energy ChatGPT takes to get one round of training as compared to how much energy you have to offer to multiple hundred homes. The consumption part of energy is huge, and energy is not unlimited. And you got to really continue to improve on the amount of energy we generate, which is barely growing at 3.4% year over year across the globe. So that need to be addressed. The second thing is the data side of it, where the AI model can only give you responses based on what it is trained on. It has to be trained on proper data, and it has to be done at scale. And that's the journey that I was talking about a minute ago that can create a challenge. The third one is the cybersecurity and all the other challenges. Now, the customers are worried that this generative AI can start seeping each other's competitive intellectual property information over, not realizing what the impact could be. They're also worried about if these large language models can be hacked into and a lot of information can be captured out of it that need to be addressed as well. So these are some of the major hindrances that can impede or slow down the AI adoption, and these need to be addressed.
Srinivas, thank you for your vast amount of experience in the area of industrial AI. Thank you very much. Listeners that do want to get in touch with you, we talked quickly before, can best contact you by LinkedIn. We'll put your LinkedIn link in the podcast notes. Otherwise, if you, dear listeners, have any question, comment, as always, please send me a short email, peter@aipod.de. I'm very happy that you stay with us so far and looking forward to have you with us again. And Srinivas, thank you very much. Looking forward to, we can discuss afterwards, latest at Hannover Messe, assuming that maybe you're going to be there.
Yeah, I'll absolutely be there at Hanover Messe. And Peter, thank you very much. I should thank you a lot. And I would like to thank every one of the listeners through you. I have had a great conversation with you. I would hope I would have another opportunity where we can take a different angle to this, talk about customer use cases and the business side of it as well. Thanks a lot.
Thank you. Bye bye.